This is Professor Antonio S. Marahas, and this is Advanced Digital Technique. Okay, so let's have an example on a three-variable map. No? So let's say we simplify the following equation using the K-map. So you have here problem number 1 and problem number 2. So how do we solve problem number 1? So what will be our solution? Again, this is a three-variable map. So we make a map representation. Okay, 8 cells again. So we have inputs A, B, and C. And this is 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. And we know that this is under A bar. This is under A. This is under B. This one here is B bar. B bar. And then we have here C. And we have C bar. Okay? So, for solution number 1, we locate this particular equation into our map. Since we are using SOP, so whatever is the location of this particular terms will have to be represented by 1. Okay? So first is your A bar, B bar, C bar. So we locate A bar, B bar, C bar into our map. So you have A bar, that means that it belongs in this particular 4 adjacent cells. And then you have B bar, so ganun na lang ang choices, duha. And then C bar, that is this one. Okay? Diba? In our rule, it says single cell which cannot be combined represents a 3-variable term. So, that means a 3-variable term, single cell. Okay? Then you have 2-variable term. How many cells? We have 2 adjacent cells. Represents a 2-variable term. So we have AB, that is in this particular area. A is here, and then B is this one. Okay, so A, these 4 cells, and then B is these 2 cells. So the intersection of AB will be these 2 adjacent cells. And then you have A bar, C bar, 2 variable terms again, 2 adjacent cells. So you have A bar, this one here, and then C bar, like this one. These 2 adjacent cells. Okay? A bar, C bar. Now, since this one here has already a value of 1, so we just put a 1 on the other cell. And then you have A, B, C bar. Where is that? You have A, these 4 cells is A, then B, these 2 cells, then C bar, that is this one. So, since nanay 1, that means nga, di na ito butangan og 1. Then you have BC. Where's your BC? This is under B, and this is under your C. So, what is the intersection? BC. So, this one, these 2 adjacent cells. Okay? Now, since there is already 1 here, so you just have to place a 1 there. So, that will be the location of your output. Okay? So, we group them according to our rule. The grouping will be what? 4, 2, 1. Actually, we can have 8, no? 8 adjacent cells because we have here 8 cells. But if, in any case, all cells here have a value of 1, then that means that X will be equal to 1. Okay? So, kung there is no 8 adjacent cells, we go to 4 adjacent cells. So, we have this one here as adjacent. Okay? And then we find another 4. Napa by 4 adjacent cells? I think there is none. Then we go to 2. Okay? Then we have here this cell which is not yet been grouped, and is adjacent to this particular cell, which is already grouped, we can still use this one to combine in this particular cell for us to have a two adjacent cells. So, pwede na ito isang gamiton para lang ma-maximize na ito ang grouping. So, that will be this particular group. Okay? So, since nag-group na tanan, then, no need to group this one because it's already been grouped into one group here. So, this will be represented by, again, this group here is under B, and this one here is under what? A bar, C bar. So you have A bar, C bar. So your equation will now be B plus A bar, C bar is equal to X. Again, why plus? Because this is product term, this is another product term, and they are logically added together. The sum of product expression. Okay, so what will be our logical circuit? So we have here AC. So you have an AND gate inverted. This one. So you have A, C, and then you have B. It's the AND gates AC complement and complement is being OR to B. So OR gate. Then this is your B. So that the output here is X. Okay? So that is for this particular problem, number 1. How about number 2? What will be our solution? Again, we make a map. So we know that this is under A bar. This is under A, B, B bar, B bar, C, and C bar. Okay? Then we locate this particular equation into our map. So you have two variable term, two adjacent cells. That is according to our rule, no? So AC. So you have this one here is A. This one here is A. Okay, and then C. The intersection of A and C is these two adjacent cells. Okay, then B bar. Where's B bar? This one here is B bar. These four cells are under B bar. So, since nakani, so you all you have to do is to put another one here, and then B bar. Okay, and then ABC. Where's ABC? This is under A, this is under B, and this is under C. A, B, C. This one. So, there is already a 1 there, so no need to place another 1. Then, B bar, C bar. Where's B bar, C bar? B bar, and then C bar. This one. So, there is already 1 there, so no need to place again the 1. Then you have A bar, A, B bar, C bar. You have A, B bar, C bar. There. So, nanagya po yung 1 niya. So, no need to place another 1. So, again, we group them. So, what will be our grouping? 8, 4, 2, 1. So again, maximize the number of cells to be grouped. Okay, so in this particular case, there's no 8 adjacent cells. So we go to 4 adjacent cells. So we have this one and this one are adjacent. So that will be our grouping. That's for the first group. And this cell here is not yet grouped, which is adjacent to this particular cell. So we use this cell here to group into this particular cell to maximize the grouping. So since all of the ones are already grouped, so you stop there and then you obtain the equation. So this one here belongs to B bar. And this one here belongs to A, C. Okay? So, the equation now becomes B bar plus AC is equal to X. So, our logical equation will be, you have an AND gate represented by inputs A and C, and then we have B. So B is being OR to AC. So we have here an OR gate, B complement, that is your X. So that will be our solution for this particular example.